In the diagram below, lines N and M are parallel. What is the value of X? Well, as we take a look here, the first thing that I notice in this particular problem is that this is 30 degrees, and it's 30 degrees because it's vertical to this angle right here. So this one here and this one there, those are vertical. So we know that that's 30 degrees. Now that we know that we have 80 degrees and 30 degrees, we can find this angle here, because 80 plus 30 plus that missing part there, which we're going to call A, all of those add to be a protractor, so 180 degrees. If we look at that, then 80 plus 30 is 110, plus A equals 180, and we subtract 110 from both sides. We end up with that angle being 70. I'm going to erase a little bit here. This is 70. The reason that I wanted to do that is it says that lines N and M are parallel. So I have now this angle of 70 that's inside, it's in between the parallel lines. And then I need to know what X is. And it is also in between the parallel lines, but it's on the other side of the transversal. So knowing that this angle here is 70 means that this angle there is also 70 because they're alternate interior angles. In the diagram below, line L is parallel to line M, and then QR is perpendicular, segment QR is perpendicular to segment ST. If the measure of angle 1 is 63 degrees, then what is the measure of angle 2? Well, a couple of thoughts here. I look at that triangle and I see that it's a right triangle, but it's the two parallel lines cut by the transversal being segment ST. So this angle and this angle are alternate interior angles, and consequently that means that this angle right here is also 63 degrees. And we know two angles now in the triangle, 2 out of the 3 of them. We know the 90 degree that was given to us, and I don't really need to write the degree there, because we want to find the measure of angle 2. 90. We know 63, and then we want to know the measure of angle 2. Again, I'm going to use A for angle, and there's 180 degrees in a triangle. So 90 plus 63 is 153, plus angle A, which is our angle 2, is 180 degrees. If we subtract 153 from both sides, then what we end up with is 180 minus 153, which gives us 27. And that's what we're looking for over here in our answers. B is 27. Letter C. Based on the diagram below, which statement is true? Well, it says angle A parallel to angle B, which is not true, but it's not true, not because it just looks like they're not parallel. A couple things that we know here is this is 60 degrees because vertical angles, this angle and that angle there, vertical angles. So that's 60. And 180 minus 60, if we look at the linear pair idea right there, gives us 120. So this is 120, and this is 60. And in order for them to be parallel, our corresponding angles would have to be equal, and they're not. So we look at line A parallel to line C. And it's going to be the same reason. We've got 110 degrees here. I'll highlight it. 110 degrees here. And we have 115 degrees there. And if those were parallel, if line A and line C were parallel, then the 110 and the 115 would have to be equal. So it's not B. We get to letter C. It says B is parallel, line B is parallel to line C, which once again is untrue, and it's all going back to the corresponding angles. The 120 is different from the 115, so that one is not. Well, luckily enough, then that must mean that our answer is D, and it is. If we take a close look, what we've got is, we've got this 120 degrees right here, we've got this 120 degrees right there, and they are alternate exterior angles. They're both outside of the proposed parallel lines. And since those two are equal, our answer to this one is D.